Hello everyone, we're going to go over electricity today, so make sure you have your notebooks, pencils, highlighters, or anything of that sort, and make sure you have your headphones as you're listening along with this video so you can hear it perfectly. So let's get started. So I want you to brainstorm right now. A power outage has just happened in your city. What actions from your daily life would not be possible without electricity? I want you to think and respond to this question right now. All right, so hopefully you had some time to respond to this. Let's keep going. We're going to see today a preview of electricity, conductors, insulators, current, and static charge. But before we get into electricity, we have to understand atoms. Well, what are atoms? Atoms are the basic units of all elements. That's the first thing that you can write into your notebook. They're made of electrons, protons, and neutrons. As you can see, I have my electrons right here. I have my protons with the positive sign, and my neutrons are the gray particles right here. So I have electrons, protons, and neutrons. The nucleus of the atom, which is the center, is where the protons and neutrons are all located. The electrons are kind of hovering around this nucleus, and we have billions and billions of these atoms that make up ourselves and make up all of matter. Well, let's first start with what are our electrons? And you notice I put electrons have a symbol, which is this E with kind of like an exponent of a negative sign next to it because electrons have a negative charge, and that's what we want to write down here. And you can draw this diagram yourself into your notebook, and you can see that protons, like I said before, have a positive charge, while an electron, again, has a negative charge. Interesting thing about these negative electrons, they are attracted to the positive protons. Just like how you might see on a magnet how the negative side is attracted to the positive side. In electricity and electromagnetism, you have these electrons attracted to the protons. So make sure you have this diagram written down. All electricity is then is the presence or flow of electrons. Okay, you see here two wires that are being close together. This bright light right here is not fire, it is actually the flow of electrons. This is electricity flowing from one end to the other. Have this picture in your notebook too, so you can represent electricity. So maybe you want to draw like a squiggly line, or you want to draw it kind of like they have in the picture. Just make sure you have electricity as the presence or flow of electrons. Let's keep moving. Again, with electricity being the flow of electrons, sometimes it can flow and sometimes it does not. We're going to first look at conductors. Conductors are materials in which electricity or electrons can easily flow. So conductors allow that electricity to flow easily. And when the current is applied, electrons move in the same direction. They move in one direction through that conductor. One example of a good conductor are metals. Any kind of metal like gold, silver, aluminum, all make good conductors. You can have these examples down in your notebook. So here's another example, a picture of it. So you might see maybe with your TV or any other electronic device, you might have wire. And within that wire, you might see copper wire that's being run through the rubber that's surrounding it. This copper right here, and you can again draw this into your notebook, this copper right here is a good conductor of electricity. It allows that electricity to flow through. It allows it to travel through the copper wire into your electronic device, like your TV. Let's see another example of a good conductor. A circuit board. So if you have a smartphone, if you open up your smartphone, you would see an example of a circuit board, or in your computer, for example. These circuit boards allow electricity to flow through the microchips that you have on these circuit boards. And if you see all these lines right here, all these silver dots, these are pieces of metal that allow the electricity to run through. And without these circuit boards, your smartphones, your TVs, your computers, or any electronic device that has internet capability would be useless. So you have a lot to thank for electricity for your smartphones. Well, what if electricity cannot easily flow? Well, then we have an insulator. That's what you can write down. An insulator is a material in which electricity cannot easily flow. It has trouble flowing easily through it. Those examples of good insulators are glass, wood, and rubber make good insulators. These materials right here do not allow electricity to flow easily. They're often used for safety purposes, such as covering electrical wires. So if we went back to the copper wire here, this is that rubber that surrounds the copper wire. So when you touch this wire, you don't get shocked. You hold the rubber so it doesn't shock you. That was an example of an insulator. So again, a rubber band is a common example that you see in school that's a good insulator. So you can even draw examples of rubber bands within your notebook. So if it's a good insulator, it makes it a poor conductor. It makes it a good insulator, but a poor conductor. So like I said, electrons can easily travel through conductors and poorly through insulators. And I want you to draw these wires, or you can go back to your drawing of wires before in your notebook, and I want you to make a diagram out of it. The exposed part of the copper wires are the conductors. These allow the freely move electrons. But the rubber part right here is the insulator part. They hold on to electrons. So when you touch that wire, the electrons don't travel to you and shock you. So it's helpful to understand water and electrical systems because it's better if we know already how rivers and dams work. It helps us better understand these complex systems that we might see in electricity. So, for example, you have the Nile River, one of the world's biggest and longest rivers, flows very easily. The water goes from south to north. It flows in one direction. Okay. While we have here in the Hoover Dam in Nevada, you have the water being blocked by this concrete dam. It's not flowing easily. If this dam wasn't here, this water would be flowing through. But unfortunately, this dam is preventing that flow. So, electrons act like water molecules in that they can flow like rivers and collect in dams. So, this water system example can help us better understand electric currents and electric buildup. So, you can draw this example into your notebook. A current in water systems, the current is a flow of water. So you see here in this picture, then in this diagram, the water's flowing in this direction. It's not like water can just stop one day and just go in the other direction. It flows in one direction consistently. Same thing in electrical systems. The current of electricity is going one direction and only will go in one direction. So, for example, when you plug in maybe, let's say, your iPhone or Android phone into your charger, and you're having at the wall, you plug in the charger to your wall, and then you plug the other end into your phone, electrical current is only going into your phone. It doesn't go the opposite way. Your phone's charge doesn't go into the wall, it only goes in one direction. Okay. So this is a great example of electrical buildup. So just like how dammed water collects and cannot flow, this water is just collecting here. That's why you can see different water levels down here and up here. Electricity can do the same thing. It can collect into one place, but cannot flow. The best example of that is that maybe you had a balloon and you it against your head and you rubbed it and you had the hair standing up. Well, what was happening is a static charge building in that balloon or static electricity collects the charge but cannot flow. Or another example, when you're at home on carpet with socks on and you rub your feet on that carpet, and then if you touch another person, that static electricity that you have flows into another person. But if you wouldn't touch another person, it would just stay, that static charge would stay within you. So think of it like this. Again, you have a positive and negative charges. Objects may gain or lose electrons from one surface to the other. Okay, so For example, rubbing the balloon on hair causes more electrons to go onto the balloon from the hair. So right now they're both neutral. The balloon's fine, then in the let's call her Sally right here. Her hair is fine. But if I would take that balloon and rub it against her hair, what it would do is that it makes my hair, or Sally's hair, excuse me, have a net positive charge. It loses electrons because those electrons flow into the balloon, and that balloon is holding onto electrons, and it's not allowing those electrons to move easily. So again, the hair loses electrons, thus becoming positively charged. The balloon becomes negatively charged. That's why we see, comparing the two balloon pictures, this balloon having more negative charges. Okay, so again, take some time to think about this. Do you think electrical current flows more easily in conductors or insulators? Take a second to think about it. You said conductors, you're right. Electrical current flows more easily in conductors because electrons move better in conductors. Another example is static electricity builds up more easily in insulators because electrons cannot move well in insulators. Okay? So let's go on to more review questions. So what do we call the flow of charged particles or charged electrons? What do we call that flow? Take a second. It is called electricity. Does it matter if they're positive or negative? No, but typically electricity is a flow of electrons, and electrons have a negative charge. We've shown that copper is a conductor. Name 3 more conductors. Look back to your notes if you have to really think about it a little bit more closely. So for example, gold, silver, aluminum are all good conductors. Think about electrician always works with electrical wire, telephone poles, excuse me, and then anything else that deals with electricity. Where would an electrician use an insulator? Take a second. Electrician would use insulator material, going back, would use insulator material either around electrical wires or around the handles of electricians' tools. Usually electricians use rubber. Insulators help to protect the electrician because current does not travel very well through insulators. That's why they wear rubber gloves and rubber insoles so they don't get shocked. So that's all I have for today. Make sure if you need to go back to any part of this video that you do that so you can get all the possible notes into your notebook so you're ready for our science experiment tomorrow. Thanks for watching.